Greetings, YouTube. Beautiful mind here. We have the following question that comes in preparation for our exam. We're asked to solve this inequality and write the solution in interval notation. So this is called a compound inequality. It's basically two this is two inequalities in one. We still treat it like an equation, right? So to solve something like this, all we really have to do, for instance, imagine that we don't have that left part, and also imagine that instead of that being an inequality, imagine that is an equal sign. So the way you solve this equation is how you solve the original. What we do to one part, we do to all three parts. So I think our text identifies this as a three-part inequality, right? So essentially what we're going to do is solve for x. We're going to get the x by itself. We're going to move the other factors and terms away from the x in the center. And whatever we do to the center, we do to all three parts. I'm a fan of organizing it by, these are like our equal signs. So I'm a fan of doing this technique. Let's see. Okay, so whatever we do to the middle, we do to all three parts. So if we want to move these away from the x, the first thing we want to do the inverse operation. For instance, if we want to move the -3 away from the x, since we're dividing by 3, we want to use the inverse operation. So what we're going to do is multiply all three parts times -3. Okay, so we're going to say this part times -3. We're going to say the right part times -3, and the left part times -3. Now, what do you notice? Notice that we are multiplying here. So if we do this, we get the following. Double negative on the left gives us positive 6. In the middle, these guys cancel each other. And so we're left with x minus 5. And on the right, 5 times -3 is -15. In class, we said that if we multiply or divide by a negative, that means the inequalities flip. So this guy flips, and this guy flips, right? Those rules still hold, they still apply, okay? So then we want to move the 5, right? So to move the 5, the inverse operation, if we're subtracting 5, then the inverse operation is we add 5 to all three parts. Okay. So I'm pretty sure that multiplying by -3 could have tripped people up, right? But this is why we ask questions. A lot of self-help gurus that I listen to, like I listen to a lot of like Les Brown, Tony Robbins, Jim Rohn, Oprah, Deepak. Shout out to what's his name? Infinite Waters of How Smart. These people are fantastic. I'm so in love with their message and what they're about. They're all about empowering people and helping people get through, navigate this realm and this life, because definitely a spiritual being having a human experience, right? So we all, we realize that everybody's doing the best that they can from their level of awareness, and all sorts of things. There was something I was about to say from them. I totally got lost in the sauce. But anyway, we'll come back. I'll come back to it once it resurfaces. Hag on it. Okay. So yeah, let's keep going. All right. So then, we're essentially there. 11 greater than or equal to x, strictly greater than, what is that, -10? All right. So now when we go to write the interval notation, we want to do this from the smallest to the largest. So to me, it's easiest to visualize the interval notation if we properly graph it first. All right, so we're going to graph this on a number line. I'm pausing because I'm trying to remember the original quote that I was about to say, and I never got it out. But it's okay. All right, so anyway. So if we were to graph this on a number line, the number to the far left, the smallest number that we see here, here's our negative 10, all right? So we have to put it in order. The largest number is 11, all right? Okay? So if our x is strictly bigger than 10, sorry, the negative 10, if x is bigger than the 10, does that mean, that means that our numbers go to the right of 10, but to the left of 11, all right? So the numbers in question, to the right of 10, but to the left of 11. So we have these guys. And then because the 11 has the bar, let me do it like this. Because of that green bar that you see there, that means that x can, ooh, that's not gonna work. X can be equal to 11, and since the negative 10 does not have a bar, we can just put them back to blue. That one needs to be a parentheses. All right, so because of that bar between the 11 and the x, that's why we did a square bracket. And then because it was x is strictly greater than negative 10, that the negative 10 got a parentheses. And so what we mean by a parentheses in this case, parentheses means, let me see, we'll do this color. So parentheses, because again, there's no bar here. Parentheses means we get really, really close to this number, but we never reach it. So no matter how far we zoom in, we can always find an infinite number of points between negative 10 and anything to the right, but we don't actually reach negative 10 because there's no bar here. Because of this green bar here, that's why we did a square bracket. The square bracket means not only do we get really, 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 really close to negative 11, but we also can include 11. Okay, so that bar means it can be equal to. Okay, so now that we have the graph, then we can write an interval notation. So just translate the graph to interval notation. What's the far left? The far left is negative 10. The far left is negative 10. The far right is 11. Again, the negative 10 gets a parentheses, and the 11 gets the square bracket. Okay. So now, say we have this solution. Oh, come on. Why'd you go away? There it is. That's fine. Say we have this solution that we want to check, right? We're saying that any number, what does this mean in the context of the original? Okay. So, is that the original? There is the original. So, if we have the interval, the open interval, the half interval from negative 10 to 11, what does this mean in the context of the original? What we're saying is that any number between negative 10 and 11, excluding negative 10 and including 11, should work in the original. So to check something like this, we choose a few test points. Okay, so with something like this, to me, the easiest number to choose would be like 0, because 0 is between negative 10 and 11. So let's just check. We're going to check a few points. So we're going to choose a few test points. So if we plug in 0, right? Let's just test 0. So let x. I'm going to say let x be 0. We get this negative 2 is less than or equal to 0 minus 5 over negative 3, which should be strictly less than 5, right? Let's see. 0 minus 5 is negative 5. Negative 5 divided by negative 3 is a positive 5 over 3. Notice that is this true or not? Notice a positive is bigger than a negative, so that checks out. 5/3 is what, 1 2/3, which is indeed strictly less than 5. Okay, so that make it true. That should make it true, and it checks out. Let's choose a number that should make it false. All right, let's do false in like this color. So a number outside of this could be, let's do 17. I'm trying to choose something so that I get a multiple of 3, just to kind of keep it simple. Notice that 17 is outside of this interval, so I'm going to say let x equals 17, right? So then if x was 17, again, we're anticipating this should be an example of something that'll make it false. So we'll have -2 is less than or equal to 17 minus 5 over a -3. And that should be strictly less than 5. Let's see what happens. All right? So we have our -2. 17 minus 5 is what, 12? 12 divided by 3 is -4, strictly less than 5. Notice the -4 is less than, the -4 is less than 5, but it is not bigger than -2. -4 is actually to the left of -2, right? So this is false. This compound inequality is false. So we're going to say this is false. All right, which is what we anticipated. So that's how we would check something of this nature. Choose a few test points, right? Choose a few points that should make it true and test them out. Choose a few points that should make it false. Okay? And so on that note, we will end the session here. And from one beautiful mind to another, enjoy the rest of your day. To my students for today, good luck on your exam. There shouldn't be any surprises, okay? I'm not trying to trick you all at this level. I'm not trying to lie to you or anything of that nature. I intend to do exactly what I said I would do, okay? So hopefully you were able to take advantage of that, and I expect you to do well, all right? Good luck, best wishes, and again, from a beautiful mind to another, enjoy the rest of your day. Peace.